Hey guys, welcome back to DIY Projects with Pete. Today's video is part of our home automation series and making your house just a little bit smarter. We'll start by installing a Wi-Fi system so we can beam internet from the house down to a shop, but you could of course do this for any outbuilding on your property. We'll go over some of the advantages of this system, the costs associated with this, as well as the overall install process. If you find the video helpful, please like and subscribe to the channel, and let's get to it. First, you'll want to figure out where to mount the transmitter and receiver so they have a clear view of each other. Now, the transmitter for this situation will be mounted on the right of the home near the ridge, and then we'll put the receiver near the peak of the shop's roof. Here's a quick look at the kits. We have the Adalov transmitter and receiver. There's a couple Ethernet cords, a power over Ethernet plug with a LAN port on the bottom as well. Some clamps to attach these to a mount if you're putting it on the side of a house or on a roof. Head up to the area you want to mount the transmitter, double check you have a clear view, and then it's time to begin the install. This kit comes with the mounting pole hardware, which you can secure to your roof or to the side of your building. I like to attach it to the fascia board to avoid drilling into the roof, but either works well as long as you use silicone or a product to waterproof where the screws go in. Connect the transmitter to the mounting pole with the provided hose clamp and direct it toward the other building. If you notice you need to adjust the pitch, you can always back out a couple of screws and reposition the bracket so it will point directly at the receiver. The wing nuts can be tightened once everything looks good. Then it's time to run the Ethernet cable to the router you already have set up in your home. Find an area on your siding or on the roof to drill so you'll be able to run the cable inside the building. Here, I'm drilling through some cedar lap siding and sheathing behind it. I actually drilled a hole with a smaller 7/16 inch bit, and after testing to see if the Ethernet cord would go through it, I realized a 5/8 inch bit was needed to make the hole just a little bit bigger. I'd recommend measuring and ordering the length of Ethernet cord that you'll need to run through the attic or the wall to get to your router. Here we needed about 50 feet, and I'll put a link in the description to the Ethernet cord I used that comes in various lengths. If you're running a cord through the attic, navigate to where your hole was drilled, and then feed the Ethernet cable through it. The other end was fed through the insulation and ceiling down through the wall and to the area where the current router is set up. All right, this is the Ethernet coming from the bridge, so we're going to hook it up to the PoE. We'll hook up the short cord that came with the kit to our existing router. And then this just plugs in. Then head back up to your roof and connect the other end to the LAN 1 port on your transmitter. Double check that the switch for the transmitter is set to A, and then push the button to adjust the channel. You can pick any number as long as it's the same number as on your receiver, and I picked the number 4 since it's one of my favorite numbers. A wall grommet will work well for a professional looking install, and then use some silicone to seal the hole and grommet area. Fasten the cable to your soffit using cable clips or organize it how you'd like. I actually ran the cable through the channel in the bracket after the video was made and used a couple zip ties to attach it to the pipe for a cleaner looking install. The transmitter is now installed, so you can head over to the other building where you'll be putting the receiver on, which in our case is the shop. The receiver is installed similar to the transmitter, and the mount is attached with 4 screws to the fascia board. Tighten the wing nuts and then clamp the receiver to the pole mount. This is what your receiver will look like once it's secured. Drill a hole to get the Ethernet cable into your building, and for us, we're going to drill through the siding again and into the attic. You'll need a second Ethernet cord to run from the receiver to a router in your shop or outbuilding, and I'm drilling a hole from the attic down through the ceiling and into the shop area, which is then pulled over the workbench area. This cable will plug into the PoE port on the plug, and the shorter white cord will go from the LAN port of the plug to the internet port of your router that you're planning to use. Now, I had an old TP-Link router just sitting around, and I decided to use it to create the Wi-Fi network in the building. The other end is run through the hole in the siding and to the receiver, and you can put it through the bracket to help snug the cable to it, and then hook it up to the LAN 1 port of the receiver. Check that the switch is set to B, which means it's in receiver mode, and then push the button to adjust the channel. The channel number should be the same number you picked on the transmitter, which in our case is 4, and it's going to blink for a little while until it's paired with the transmitter, and then it will quit blinking. The green lights toward the top indicate signal strength, which is looking good, so you can organize the cable with some cable clips and seal the hole and grommet area, and that completes the install of the receiver. The transmitter on the house has a clear view of the receiver, and you can adjust them if needed to make sure you are getting the best possible signal. The signal is rated to go up to about 1.9 miles, and we're going about 500 feet for this setup. Lastly, you can set up your router for the outbuilding and name the network, and you'll be good to go. We now have YouTube TV going with the NHL playoffs, and then internet for the laptop, for music, for security cameras, or whatever you'd like. In doing a speed test, we're getting around 87 megabytes per second down and 25 up out in the shop, which is about 500 feet from the house, which is plenty of speed for our needs. Because this home is in the mountains, Starlink is our option as an internet provider, and I installed an antenna on the roof about 9 months ago. It's worked awesome. In the house, the transmitter, as I'd shown earlier, is hooked up to our TP Deco mesh router system, but you can hook it up to whatever type of router you have or directly to the spare port on the back of the factory Starlink router if that's your internet provider. Now, the download speed is around 227 megabytes per second inside the house, so we do lose a little speed over the 500 feet to the shop, but it's still plenty for what we need. Cost is around $104 to $150 for this point-to-point system with the mounting poles, and I spent $35 on Ethernet cords and used an old router we had laying around. Now, there's lots of different brands out there for point-to-point systems, as well as more expensive options that may help increase speeds, so find the brand and solution that works best for you. This is not a sponsored video. I was just happy with the product and how easy it was to set up. I've installed a few systems where there's things that got quite confusing for me as someone not great with networks, but this product just paired up instantly once I installed it and picked a channel. So I feel good about recommending it to someone who isn't a computer guru, but does have basic knowledge of setting up a wireless network. Hopefully this gave you an idea of the process so you can beam internet across your property as easy as it was for us. All the items used in today's video are linked to in the description in case you need to pick anything up. And consider giving the video a like if you found it helpful, and subscribe to the channel. Comment below if you have any questions or to let us know what worked well to beam internet at your place. Cheers!